Good morning. This is Priyan from Sri Lanka. Would like to thank for the opportunity provided to present at the SEKE 2017 conference on the topic an ontology-based knowledge management system for software testing. My presentation outline contains background and motivation, research questions, designing the software testing ontology, designing the knowledge management portal for knowledge retrieval and sharing, and then discussion. Let's start with background and motivation. So, as we know, software development activity contains different phases where each phase depends on the knowledge software engineers to carry out the development task. At the same time, software engineers need to collaborate with other software engineers working in other phases to share his or her knowledge or to acquire knowledge and experiences. That is why we say software engineering is a knowledge intensive activity. At the same time, organizations should encourage individual knowledge to be accumulated throughout the organization by a continuous dialogue between tacit and explicit knowledge. Then there will be a proper knowledge sharing culture or knowledge creation culture. That would encourage unstructured knowledge creation culture, or that would encourage capturing knowledge and knowledge knowing who knows what, like that. Software testing is an important activity in quality assurance and which is a part of software engineering development phase. In such situations, software testing also generates a large amount of knowledge during the software testing activity. In such situations, to manage software testing knowledge, software companies should use knowledge management principles and knowledge management systems. In this manner, we outlined our objectives for this research as follows. Objective 1, to study and develop a software testing ontology to manage software testing knowledge. Second objective is to propose an ontology-based knowledge management system for sharing and retrieving software testing knowledge using semantic web technologies. Based on these two objectives, we are able to design 3 research questions given great importance to knowledge for software testing. The research question 1 is this: how can domain ontology be designed to describe software testing on knowledge? Research question 2, how can develop ontology be used to retrieve and share software testing knowledge using semantic web technologies? Again, research question 3, to what extent is this ontology for software testing effective compared to the current practice? So before starting to understand about software testing ontology and what has been done so far in the literature, be able to do a systematic literature review on software testing ontology and be able to find 3 domain ontologies that have been discussed very popularly in the recent literature. Even though they are present, each of them were limited to some extent. For example, here you can see the domain coverage. Each ontology is covering some general knowledge of software testing ontology, some are part of ontology process. Software unit testing is implemented, that means a part of software testing process is described here. And you can see in the next slide, ontology, they have didn't mention about the vocabularies, and also they haven't mentioned about the standards, how they have been used. Ontology evaluation methodologies have not been discussed, and also very importantly, they have not discussed much about implemented as knowledge management system, which is very important for our purpose. Therefore, we decided that the previously discussed most proper ontologies are not enough for our task, but we will use these 3 ontologies for our as a base to design and develop our own ontology for software testing. So here to start this, we looked at the 2 standard documents that are considered to be described the software testing process. One is very famous, IEEE 829 2008, which is also known as the 829 standard for software testing, software and system test documentation. And other one is a very popular one, ISTQB, International Software Testing Qualifications Board, which is published in 2008, and it has different versions in recently. And also this research is conducted in a software industry, a software company in Sri Lanka. So we also considered, therefore we also considered what companies are stipulating in their practice. To designing of software testing domain ontology, the main purpose of designing is of our ontology sharing, retrieval, and representation of software testing knowledge. Therefore, we have to look at all what type of things we need to be included perfectly. So we looked at our literature, and also we decided to formulate the design our ontology based on 7 points. Here it is highlighted. One is domain coverage, second is international standards, third is implementation of relationships and axioms, evaluation of ontologies, reusing of ontologies because somebody can use our ontology. Also we used the base ontologies I described from the previous slide for our purposes. Also vocabulary standards, we have some variable standard in conventions, naming conventions in our variables, and also product as a knowledge management available as a knowledge management system. So we considered all 7 points, and we have implemented all these 7 points in our developed ontology. To design our ontology, there are many methodologies expressed discussed in past. For example, methodology, onto knowledge methodology, ontology development 101, which also there is a one in which is very old, but it's actually the base for all these designs. Methodology for the design and evaluation of ontologies, it's a Green and Fox methodology, which was discussed in 1995. We have selected this Green and Fox methodology, which used to use here because it's a formal approach to design an ontology, and also very popular with of the 1589 citations it has so far. So this is the way of the design approach. So motivating scenario is about why the software testers are suffering from knowledge retrieval and sharing. So that is our base, and we make our informal competency questions. Basically the competency questions are designed for also describes the structure of the ontology in the describe the structure of the ontology. So the competency questions we make will give the structure of the ontology. Then we use the description logic, because we are not using the first order logic, but we are here using the description logic because we are going to use web ontology language for in this our approach. So then we make our formal competency questions, then we use description logic axioms are designed, and again we see the completeness theorems by implementing whether we have everything is implemented inside the ontology. So as I said, contextual information, which is very important. Contextual is the context of particular context. Here is the software testing experts, we get it from domain experts and systematic literature review, all the context information for software testing describing the software testing process, all the process were included. And we also use OWL, which is based on description logics, and also we use Protege 5.1 for environment is used in our design approach. Also, as I said, competency questions is also is described in the same paper. The CQs are a set of questions that the ontology must be able to answer its axioms. So we make our structure here. For example, one example I show from my ontology, which human resources are part of any organization team but located in northern branch, and the size of their team is medium. So you can see the human resources are part of an organization team is a part of a relationship, and its location is another relationship between where it is located, and the size of the team is also described as medium. So this is how the structure is made, and in this ontology using the CQs. Right? So we made a lot of CQs here, and after the CQs we also used to evaluate them later on. So here this is a part of our ontology is the whole part, but actually speaking this is a one simple screenshot. I took it for my presentation because it's a huge lot of parts with 1300 axioms and everything. It's a lot of this complicated one, so I just made it a simple one for you. Okay. Then let's go for the taxonomy of artifact concepts. So you can see that here the artifacts are is one concept in our software testing ontology design, and you can see the artifacts can be derived as three sub disjoint classes or concepts: document and code and data. And document has a lot of activities here, subclasses here. So procedure specification, analysis report, test results, test design specification, case, issue, plan, test code, and code to be tested under code. Data has actual result, expected results, test case input. So these are very almost all these information were derived from the documentation and previous studies of the from the this one. So you can see the taxonomy, the hierarchy is clearly explained and the relationships are given here. So this is how it's just a part of it is, and this is how we explain our ontology. And then we evaluation of CQs, as I said, SPARQL query is used to evaluation of the CQs. So for example, I use the simple list all human resources that are part of organizational team B but located in northern branch, and the size of the team is medium. So this is one very simple example for to answer my query. So select, I say want to know the human name, and where human name is ontology B, and D is a part of medium, and the size B also has this northern branch. So I will get the results when I have the instances are stored in my ontology. Then once we designed our ontology, we need to design our knowledge management portal, which is our main important thing for our ontology. So the architecture of the knowledge management system is explained here. I have 5 layers, like experience sharing layer, storage layer, ontology layer, reasoning layer, knowledge retrieval layer. So here experience sharing layer is actually where software testers they share their experience in this while they get something from their experience, they try to share them. And also they use this ontology cloud or all described ontologies as a base to use their experience to share their experience. So the stored layer, which has all the information inside the semantic storage. So then we use some reasoning algorithm, reasoning layer to do our reasoning part. And later on we also get the new knowledge using the reasoning layer, which also will be stored in the semantic storage using the. Then later we do is we get our knowledge retrieval layer, which has our search and advanced search search and advanced search options to see our active results in a different way with a combination, so like that. So 3 type of information is stored in the experience sharing layer: general, general and test case and test result. So they can express about what is the project they have worked on, what is the test case details, and then the test results details. They can share their experiences in these 3 type of information will be they have to fill all these 3 type of information while they are working on the experience sharing. And for the storage layer we use Jena triple database, which is a triple store which stores RDF triples and are queried using SPARQL query, because we want to use some SPARQL query for our retrieval and sharing purposes. As I said, in the knowledge retrieval advanced options, you can see here we can search for project. We use some or not logic operators for our search operations. And you can see here, as I mentioned we have use some standard naming conventions. You can see here I have used starting from hash, then we have some capital letters starting from software test, and also like the kind of a formality which is explained in the previous documents, all these referred documents. So we used all these type of data naming convention for our purposes. So which is easy for the reader to understand and get get through the document. And once we designed and implemented our ontology, we need ontology verification and validation part to verify and validate whether ontology is okay. Ontology quality of an ontology should be verified and validated. To prevent content, why we do this? To prevent content ontology with anomalies or pitfalls or inconsistent, incorrect and redundant information. We use three methods to do this. One is we use some internal way and ontology experts and field study. So internal methods we use some reasoners and ops tool. Reasoners in sense we used the reasoner which is inbuilt, reasoners that are inbuilt in Protege 5.1. For example, Fact++ 1.65 and Hermit 1.3.8.1413 were used to check the internal consistency and inferences in the reason of the ontology. And also we used OPS, it's an ontology pitfall scanner, which is also popular, and ontology online ontology evaluator. Now it has been inbuilt in the plugin, also one popular one. So that evaluates 6 things inside the ontology: human understanding, logical consistency, modeling issues, language specification, real world representation, semantic applications. So for example, while at the beginning of first time when I do my OPS scanning, I got some errors here. You can see here missing annotation is one example. I got 256 cases because I didn't write any annotation, because I didn't include any annotation properties for each and every concepts described in my ontology. So that has to be, it is a very minor case, but anyway it has found 256 cases there. And also missing domain or range in properties, there's another example. That is I couldn't mention some domains inside the ontology, so it has found 7 cases, but it is important because without domain it is not good. For domain and range are very important one inside the ontology. So it has highlighted 7 cases as important when I restored them here using OPS. So that this way we able to do the internal way of evaluation of ontologies. And then we use ontology expert evaluation performed by 2 experts, ontology experts working in Sri Lankan University. One is in professor in software engineering, other one is senior lecturer in software engineering. Duration of the evaluation took 3 weeks to evaluate the ontology, meets its requirement and standards, concepts, relationships, axioms were they checked all these things are correct. Coverage of software testing process, they also looked at software testing process, the coverage of the software testing process, because it is very important for them. Checking for the internal consistency is also done by them. They used evaluation methodology. There were several methodologies to evaluate. They use Randatics evaluation method, which is 170 has citations and is very popular for among others. I guess they use vocabulary, syntax, structure, semantics, representation, context. All these were checked using this evaluation method of this paper. The summary of the evaluation results are here. So they use Manchester's index was reported as Manchester's index was used. Taxonomy, it follows is a relationship. Onograph RDFS subclass of form a single node to 5. CQs provide clear idea of the ontology structure. Complete software testing process. No inconsistency with fact plus. URIs could be shown, and also in the negative comments were given URIs could be shortened because my name is Shangunathan Vasandapriyan, so I used my login name as like something like that username. So the long URI was presented in my ontology, so they asked to shorten it. Very it's useless to have that type of a long name there, because of the username it came as inside the URI. Then rewrite English grammar for some CQs, because CQs I just use some command English. So they asked me to rewrite English grammar for some CQs, also highlighted in my evaluation of their from the ontology experts. Then the final one is field test evaluation. Actually, knowledge management postal was our company C, the VD and the VD demo was present. Actually speaking, this is actually a part of my research, my PhD. So at the beginning, when we were conducting some studies in to see whether knowledge management, how the knowledge sharing, knowledge management activities are happening in software companies. So there was a software company. They told that software testers are really having facing difficulties in understanding of sharing and retrieval of software testing knowledge among others from others. So therefore this company C, that is we called as company C, so for them we try to give the solution from our research, that is actually say called as company C. The question here was given as in English 5-point Likert type. Total number of questions we just give 10, so there were 3 questions in each, and then user satisfaction. So main objective software testing knowledge is expressed in our ontology. Support software testing knowledge sharing, support software testing knowledge retrieval, whether we want to see what are the sharing retrieval testing given, and user satisfaction is given there. So these are the main evaluation testing objectives. And 2 software testing groups were selected because of to get some comparison and in-depth understanding. So in each total of 21 people was there in these both groups. One is for 12 people in one group, and other one is 9 people in the group. So we just show some results obtained from them. Here you can see the following the standard, whether the ontology is following some standards, naming conventions, and the variables discussed everything. So the most of them have given that it is following, they are satisfied with our standard things, even though there are some people try to give some negative, they were neutral, but still they have, there are big kind of more than 50%, 2/3 of the people have given kind of they have accept our work in their point of view. And provides sharing software testing knowledge. Most of them were neutral in one company, a group A, and in the group B they have given like they are satisfied with the work, because it depends on the how they search and retrieve knowledge, share their experience. Sometimes they may face difficulties in sharing some of their experiences, so that has to be considered in future. And also we also search for the search functionality, so same type of experience, kind of it's a kind of new knowledge will be there. So we had to find again the re-engineering work, we had to find out what kind of problem they face on this type of activity, search and retrieval during the search and retrieval, and will be considered in future development. So, okay, finally discussion. So software testing ontology was design, standard definitions, vocabularies, concepts, properties, axioms, and relationships were included. The contextual information is well formalized for the software development company C's need. That's why I say the company C, they need our contribution towards to find their solution for knowledge sharing and retrieval. Ontology was verified before it has been used. The knowledge management portal was designed using the standard methods, tools, and languages. Therefore, it can be used by anybody in future. And now we have already hosted our ontology online, so anybody can use that in future purposes. They can refer us. The ontology expert evaluation was conducted, field study was conducted, and overall 80.95% of the respondents would like to recommend such knowledge management portal could be used among the software testers for knowledge sharing and knowledge retrieval, which is a successful. From this we can see that the software testing company would like to need our would like to get our guidance for their software testing activity in with respect to knowledge management, especially the sharing knowledge and retrieval of knowledge, software testing knowledge, and the new knowledge. Main limitations and difficulties at present, knowledge management web portal focus on the issue of knowledge sharing and provides a simple way of for knowledge searching. Still, it has to be employed with many participants to evaluate and validate, because we have to improve. This is actually the first level we implemented and given them. So we have to do with more evaluation, and we have to do a lot of re-engineering work. There is no much method to upload project, because that is also one complaint, negative feedback we got, that we couldn't provide them some experience. They can upload some screenshots or some tests to for their sharing experience. We didn't have that enhancement yet. Then finally, the future work, as I said, improving the sharing and retrieval functionalities to retrieve software testing knowledge, extend the coverage of software testing ontology, and expand the evaluation with many ontology experts and non-experts. Since host ontology is going to be used by several employees inside the software organization, therefore improving the scalability, usability, availability, and performance should be considered. A great need for more studies in the field to generate support in software testing processes from the knowledge management perspective. And some references what I mentioned in my presentation. These are just for my references. And thank you. You can contact me using this email, priyan@apsise.sub.ac.lk. Sorry that I couldn't make to visit you for this conference, but we sure lively because of the delay I got in getting my USA visa to travel USA. Sorry for that, and thank you very much, Professor Chang, for giving me an opportunity to present this in this as video. Thank you everybody for listening to me. Please contact me using this email for your future references or anything to be asked. Thank you. Have a nice day.